Good morning, everyone. Thank you for joining us for this panel session, Going Deep on Artificial Intelligence. My name is Michelle Davies. I'm the Director of Partnerships Development at the Ontario Centres of Excellence. I'd like to remind you that if you're tweeting today's session, please use the hashtag OCE Discovery. We're fortunate to have a strong talent base for artificial intelligence here in Ontario. In fact, less than 2 months ago, Toronto welcomed the new Vector Institute as part of the Government of Ontario's efforts to position the province as a world leader in AI. The Vector Institute will promote and maintain excellence in deep learning and machine learning and look for ways to enable artificial intelligence as a driver of economic growth. We're honored to have panelists with us today from 3 of the leading AI institutions in the province. They are the forefront of AI, where it's going, and what it means for the future. Our first panelist is Tomi Poutanen. Tomi is one of the founders of the Vector Institute, as well as co-CEO of Layer 6 AI. Welcome, Tony. Our next panelist is Daniel Mulet. Daniel is Associate Director, Machine Learning at the Rotman School of Management's Creative Destruction Lab at the University of Toronto. Prior to joining the lab, he led a business development team in the solar industry. Daniel also spent 3 years working in international development at the United Nations in New York. Welcome, Daniel. Our next panelist is Graham Taylor. Graham is the Academic Director of NextAI, a nonprofit initiative to establish Canada as the AI hub for research, venture creation, and technology commercialization. He's also a member of the Vector Institute and assistant professor at the University of Guelph, where he teaches courses on machine learning and software engineering. Welcome, Graham. Graham is going to be standing up and doing a short presentation this morning on AI to give us an overview of artificial intelligence and where it's headed. Welcome to the podium.
Thank you very much for the introduction, and it's really a pleasure to be here. It's really quite an incredible time to be working on artificial intelligence, and it's great to be here in Toronto, the birthplace of some of the most fundamental discoveries and contributions to modern AI, and also the place where the future is very bright for AI research and commercialization. I've been asked to introduce this session on going deep into artificial intelligence, and I'd like to do this in 3 short parts. I will share my perspective on what AI means, how it relates to machine learning, and how and why machine learning is so powerful. Next, I will discuss where I think AI is headed in the near future and how it contrasts with today's state of the art. Finally, I will address some implications of wide-scale AI adoption and emphasize the opportunities it affords. So first, AI. Collectively, our exposure to AI has been through popular media, including sci-fi. It has been presented as utopic or dystopic, but undoubtedly the phrase carries much weight. Today, it is an active scientific and technological discipline which fuels an increasing amount of economic activity in this province. Those of you who have seen Siobhan Zillis's machine learning landscape understand the breadth of sectors which it impacts, from agriculture to finance. Why we are here talking about AI is because of machine learning. Not all intelligence needs learning. For example, there's some thermostat that's been programmed in this room to keep the room at a comfortable temperature. There are software engineers that have worked on developing tax software to help you with your tax returns in a reasonably intelligent way. But some programs are really next to impossible to program by humans. Who out here is a software developer? Okay, a few of you. So I think you would understand how difficult it would be to write a program to drive a car, right? Amid all of the weather, the road conditions, the other drivers on the road, it's really hard. So it's much better to actually let this program be written by machine learning. And that's why machine learning is so powerful. And it's really advanced AI. It is the automatic construction of computer programs, and in most cases it can create programs much more efficiently than we as humans can create, and it can also solve a lot of programs that are just impossible for us to write. So where is AI going? First of all, many of you have already interacted with AI through internet search, recommendations through Amazon or Netflix, or maybe face recognition in a Photos app. But this has always been behind the internet. There's always been this gap between you and the machine. And this is because machine learning has largely existed in the cloud, essentially a brain in the box. But advances in an area called reinforcement learning mean that machine learning is moving from inside the cloud into our physical environments. And I don't think it's too long before we'll see intelligent robots in the places that we live and we work. Secondly, the machine learning systems that I've described so far are largely predictive systems. They produce fairly simple outputs. But now we're in a world where machines are creating music, art, prose, and dialogue. I use a machine learning application to respond to approximately 5% of my emails, but I've not quite yet shifted my taste to computer-generated music. The third advance I'd like to mention is a bit more conceptually challenging. There is no single best architecture or learning algorithm. These are largely the product of human ingenuity, like the graduate students in my lab that work on these problems. But it will be a major inflection point when machines learn how to learn. And this so-called meta-learning is receiving a huge amount of attention in the research field. From the cloud to the physical world, from prediction to creation, and from careful human construction to machines building learning machines, this is what's coming. The final topic I'd like to discuss is more challenging for me. As an artificial intelligence researcher, I find myself doing more interviews and more panels like this in the media and at public events. AI is a hot topic, and people want to know more about its impact on society. For a long time, I shied away from these questions, stating that I worked on the technology, and I really wasn't an expert on matters outside of that. But it was in with communications training with CFAR's Israeli Global Scholars Program that convinced me that discussing these matters in public were indeed my responsibility. So let me discuss a few points of concern. There will be job disruption. Historically, there has always been some job loss associated with new technology. Printing press, steam engine, personal computer. Where I see this occurring is along two axes, and I credit this to Ajay Agrawal, who works with NextAI and is a professor in economics at University of Toronto. One axis is that the jobs that are purely physical, so repetitive work on the assembly line. Another axis is jobs that are purely cognitive. For example, those tasks, many of which are done by paralegals, or for example, radiologists. The jobs that are less likely to be disrupted are those that lie between these two axes. Again, jobs that are not purely physical or not purely cognitive. I had a similar conversation with my dental hygienist not too long ago, and I assured her that she would not be replaced by an AI anytime soon. As we have experienced throughout history, new technology will create better opportunities for prosperity. I think that developments in AI will create more engaging, meaningful, and creative work. People will be hurt by AI. For example, fake news or other content designed to deceive, more intelligent cyber attacks, or even, in particular, as AI moves from the cloud to the physical world, the possibility of injury or loss of life. However, as my colleague famously said, just because backhoes can kill someone doesn't mean we should ban backhoes. We need to support research on both AI technology, but also AI safety. And several entities like the Future of Life Institute, OpenAI, and the new CFAR program in AI for Society are leading the way to ensure the safe development and deployment of AI technology. My final thought is that a lot of the AI technological capability rests in a few companies, namely the internet giants, who have made tremendous investments and experienced growth in this area. And this imbalance is a little unsettling. AI will only succeed if the abundance it creates can be shared by everybody. All humans, all machines, and everything in between. This is why I'm so excited about initiatives like Vector, CDL, and NextAI. We are working to build Canada's capacity in AI so that it continue to lead on a global scale. We will collectively train more graduate students, more young entrepreneurs, and more business leaders than anywhere else in the world. AI will continue to generate technologies that will really change lives for the better. Amid growing populations and climate change, my lab is collaborating with Guelph's Food Institute to apply machine learning to sustainable growth, production, and consumption of food. Personalized medicine is another area that's fascinating and being driven by AI. And even the little things like finding a parking spot won't be as hard or frustrating in the future with AI. So in conclusion, AI is exciting and it's attracting a lot of attention. It's posing some challenges, but many more opportunities. It's happening, it won't stop, and we need to get on board, learn about it, and shape it towards the future that we want. Thank you.
Thank you, Graham. As the mother of a 23-year-old and an aunt of a 21 and 24-year-old, I'm very excited about the future that Graham's just painted and what it means for jobs and what it means for the lives that we will all be leading in the future. So we appreciate the overview of the AI landscape that you've provided, and now it gives us the opportunity to dive a little deeper on our panel. So now I'll turn things over to Tomi to lead the discussion with his fellow panelists. Welcome, Tomi.
Thank you. Can you hear me all right? Okay, so we're going to conduct the rest of this as a fireside chat without the fireplace. I thought it would be appropriate for us each to start with an introduction on ourselves and also the organizations that we represent. So I represent the Vector Institute, Daniel, the Creative Destruction Lab, and in addition to being a professor in machine learning, Graham also represents a NextAI organization, and all three of those are meant to help us be a leader in AI and help Canadians prosper from the benefits of AI. So let me start a little bit about myself. Formerly a tech entrepreneur from Silicon Valley who've moved back here. I have known Geoffrey Hinton for many, many years. I studied at my grad school at University of Toronto. But in Silicon Valley, I worked on machine learning applications. In fact, I wrote Yahoo's and Microsoft Bing's machine learning ranking engine, which was the largest machine learning stack in existence in 2011. And I came back here. I currently run an AI company called Layer 6 AI. It's Toronto's largest AI business, helping large enterprises use AI in their organizations. But what I've been doing over the last year is I've been working with Jeff and University of Toronto and the Ontario Ministries of Economic Development to build the Vector Institute, which I think a lot of you heard about. It was announced at the end of March, and it received a tremendous amount of support. It now has raised $190 million to build a school, if you will, for artificial intelligence that celebrates the academic achievements that have come out of Toronto. And that's not necessarily known by everybody. It certainly is more publicized these days, but for a long time it wasn't known to Canadians that the greatest advances in artificial intelligence came from Canadian universities. I'd say most of those came from University of Toronto under Jeff Hinton's leadership, and Graham is a PhD student of Jeff's, so he has a very interesting perspective on it. But It's an amazing Canadian success story. It is a group of Canadian researchers who were funded by organizations like CFAR, NSERC, and CFI. So a number of government funding agencies supported curiosity-led research. And this research was long in making. It literally took, Jeff Hinton moved to Canada in 1987 to escape some of because he said the only research funding he got in the US was from the US military, so he wanted to come to Canada and do AI safely. And he was the original author of an algorithm called backpropagation, which helped train neural networks, and that was back in 1986. But it didn't take him until 2001, 2012 to really prove that his line of research worked. And during all of that time, it was a unique group of Canadians who were advancing this field and were being supported by these granting agencies. And when his field of research called deep learning really showed what it can do, a lot of the international AI computer science community woke up to it. And unfortunately, while the breakthroughs were made here, most of that talent, intellectual property, most of those individuals moved to the US, where that's commercialized. You see that now that researchers have come through here are leaders in places like OpenAI, Google Brain, DeepMind, Apple, Facebook, Microsoft, and Amazon. And it's great that we came up with these innovations, but as Graham said, there will be AI and automation will have great societal impact, and it's not just good enough for us to be academic leaders. We need to also distill this into industry. Analysts have said there's two outcomes to AI and automation. Number one is half the jobs are at risk of being displaced by automation. On the other hand, they say GDP growth per capita will increase by twofold for industries and jurisdictions that embrace AI. So when we presented the idea of a large institute dedicated to AI, our question to the government is, well, which side of the coin do you want to be in? And it certainly is more beneficial for us as a society if we're leading that effort. And to Kathleen Wynne's, the credit to Kathleen Wynne's government, the Ontario province was the first to recognize the importance of this thing and the fact that we have this reputation. We have Jeff Hinton. We're going to look back in 20 years and say, we had Einstein here. Why didn't we do something about it? So to their credit, they were the first ones to write a check. They wrote a $50 million commitment. And from there, we went to industry. A lot of the executives of all the large Canadian banks and manufacturing giants and even building companies like Ellis Don, they came together and said, yes, we're going to support this effort. So we raised another $90 million from over 34 companies. And the federal government, with its pan-Canadian AI strategy, is supporting us, as they're supporting Montreal's Mulet effort and Alberta through their AMI Institute. So that's a little bit about the Vector Institute. It aims, as Graham says, it aims to be a top academic institution in AI. It has very specific goals of graduating more PhDs in machine learning, PhDs and masters in machine learning than any other school in the world. Its goal is to help Canadian companies succeed by understanding and reforming their enterprises with an AI-first approach, and we also aim to help build an AI ecosystem. Now, for the AI ecosystem, we're not alone. We're not an incubator. We're a feeder system to other programs like the CDL and NextAI. So I thought it would be appropriate to introduce Daniel next and have Daniel talk about the CDL and also Daniel's personal interest of what brought you into AI in the first place.
Sure. Thank you, Tomi. You might be wondering why I'm sitting between two of the coolest people in AI right now. And I was wondering the same thing when I was asked to speak on this panel. And the only thing I can think about is that over the last 2 years, we've had 75 AI companies at the lab. So I've worked hand in hand with really inspiring, truly visionary entrepreneurs who are building AI businesses, both here in Ontario and Canada, and they all fly to Toronto 5 times a year to meet with our mentors. And I'll get into our AI program in a little bit. I'm going to give you a bit of background about the lab, why it was started, how we operate, and then we can go from there. We're a seed stage program for massively scalable science-based companies. What that means is that the companies that do best in our program have raised very little capital. They have deep, gnarly technology at their founding core. So usually it's people who've toiled in an academic research lab for a few years, they want to commercialize their PhD work, or it's a startup that's been around for a few years, they've developed some core, unique, interesting technology, but they haven't quite figured out their product market fit. So from a founder's perspective, they come to the lab. The program starts in September of every year. It runs, the core of it is 5 meetings that run every 8 weeks. And the founding principle, which is a very simple but yet powerful idea, is that if you are a first-time entrepreneur and you're building a company, the best people for you to seek advice from are people who've built companies before, people with judgment. We went out, we found initially 7 of these people, we call them the G7. That's quickly expanded to about 20 or 30 individuals from the Toronto area and increasingly from around the world. They fly here for these 5 mentorship sessions. Tomi is one of them, a number of local Toronto people you might know, Ted Livingston, Mike Serbinis, Dan DeBow, David Ossip, a fellow by the name of William Tunstall-Petto, who founded Eevee, acquired by Amazon in 2012. His technology now powers the Amazon Echo. So he flies from Cambridge, UK, 5 times a year to meet with Toronto, Ontario-based companies. A number of people from the Valley as well, including Siobhan Zillis, who's an investor for Bloomberg Beta. I won't go into the nuts and bolts of how all the mechanics operate, but there's a roster of chief scientists who do technical advisory work for the companies. They help them build out their technical roadmap, and these are leaders, true leaders in their field, from computer science at the University of Toronto. Russ Alkudinov, the head of AI research at Apple, is one of them. Raquel and Rich here from CS now. I haven't gotten used to calling it Vector yet, Tomi. People like Steve Mann, the father of wearable computing and electrical engineering here. So truly at the height of their academic fields, they vet the technology and they provide guidance to the founders to make sure that what they're building is really on the cutting edge. In the background of all this, we've got a class of MBA students. About 100 of them are deployed in teams of 2 to work with the founders, and their main objective is to help them execute on the advice that they receive. So if in the course of a 9-month program, which is probably longer than most accelerator programs out there, the core focus is to build the companies, de-risk them as much as possible for some kind of investment scenario at the end of the 9 months. The way we achieve that is setting objectives. So it's every 5 months there's objectives that are set. They're the top, the 3 most important things that when you wake up as a founder, you've got to go out and just solely focus on those 8 things. So for 8 weeks, for 4 weeks, you're sprinting towards that. That's also part of the reason we're able to do this without charging any fees for the companies. We don't take any equity, is that we have this educational mandate to graduate fewer bankers and consultants from the business school and more entrepreneurs or people with entrepreneurial mindsets. So that even if you do go and you're a project manager at a bank or at an agri-tech firm, that you're approaching it from an entrepreneurial mindset where you're trying to build something greater than what you were given. So that's a little bit about the lab. I'll talk about the AI streams. I guess 2 years ago, or before I go to that, we're definitely complementary to everything out there. So in most cases, companies will be in NextAI at the same time. They'll be at DMZ, they'll be at Mars, they'll be at YC, Techstars. We're a very light touch thing because we focus on the high level objectives. So 2 years ago, we made a bet on AI. We didn't know if it was going to work out. We went out and recruited 7 new mentors, exited entrepreneurs in AI. When we started this, we were, as far as I know, the only accelerator type program focusing specifically on AI. Now there's about 30, somebody sent me something recently, there's about 31 of them globally, and they just seem to keep proliferating. So what we have at this point is a bit of perspective on seeing all this range of companies that have come through. 25 in the first year, 50 in the current year, and we'll get into this a little bit later, I think. But what's been very interesting is that we went from a very Toronto-centric program to a program that now attracts international talent to Toronto. And I think that's important when making a bet on the strengths of the local ecosystem. You start and that local ecosystem is not just strong locally, it's strong globally. You start attracting people from all around the world who want to come and see what's going on. We've got companies from Boston, from Palo Alto, from NYC, from Seattle who are in the program right now. And I guess I'll finish off by saying that in conjunction to all this, we run a conference on the nexus of AI and academic AI. This happens at the end of October of every year, and it kicks off our AI cohort. So that'll be at the end of October this year.
Okay. Yeah, thank you, Daniel. So turning over to Graham, so in addition to your very busy schedule being a professor, you're also taking the time to help with the local ecosystem in developing, being the scientific director for NextAI. So can you talk about NextAI and how that helps the ecosystem?
Sure, I'd be happy to. So NextAI is part of a larger program, Next Canada. And Next Canada is a nonprofit organization whose mandate is to increase national prosperity by creating an ecosystem for the most promising founders, innovators, and entrepreneurs. And Next Canada runs 3 programs. There's the Next 36, which looks at very high-performing, promising undergraduate students in their final year who want to build a company. There's Next Founders for companies that are started and basically need a bit of a boost and further founder development. And then there's the Next AI program. So all of these 3 programs are based on the idea of founder development. So this means not just financing, but also mentoring, networking, and of course, education. They all have an educative component. So I'd like to talk about the program that I'm involved with, which is the newest program within Next Canada, and that's called NextAI. So the idea here is to build on Canada's existing strengths, the leadership in AI, and all the excitement around this area, and seeing how many companies are actually building this kind of technology into companies. Recruiting, not again, just like the previous programs in Next Canada, recruiting not within Canada, but abroad. So this year we started NextAI. We've recruited 20 different teams who have AI technology that they're building, and a total cohort of between 60 and 80 students. They come not just from an undergraduate background like the Next 36 program. They can come in as undergrads, they can come in as graduate students, they can come in as people that have already been out working in industry for a while. What's provided to these teams? First, they have access to up to $200K in capital over the 7-month program. All teams are guaranteed $50K capital in seed, but the higher performing teams actually have access to more capital as they progress through the program. We have world-renowned faculty, both on the business side and on the technical side as well. So my role as academic director is to bring in the best and brightest to come and teach courses within the program. So just to give you an idea of the type of curriculum that we have on the technical side, I offer a course on machine learning and deep learning. We have Joël Pinault from McGill, who's also involved with Facebook AI research now, who's an expert on this area called reinforcement learning that I mentioned. We have Sanya Fidler and Raquel Erdison. Raquel and Sanya are both professors at the University of Toronto. Raquel recently joined Uber as a director in research there, and they teach on computer vision, just the ability to teach computers how to see. And we also have Kyung-Young Cho from NYU, who's a world leader on natural language processing. And then for the final stage of this technical curriculum, we bring in business leaders from companies like Kindred AI, Google, Microsoft, IBM, NVIDIA, and they come into the program to share their experience of building a company, the more practical day-to-day deploying AI in practice, AI optimization, AI safety, these sorts of issues. Finally, beyond this educational curriculum, we have access to a wide network of business and technical leaders, and of course, access to the best tools. So we have Google, IBM, and NVIDIA as technical partners who are providing the cutting-edge software and hardware tools to all of these teams. The program is pan-Canadian. We've attracted teams from all over the country, but we also have 25% international participation. And it's a 7-month program, as I mentioned, that culminates with Founders Day in September. So if any of you are interested in seeing what these 20 teams have been up to on September 20th, please get in touch, and we'll get you invited to the showcase event, which will be held in Toronto.
Great. So for the balance of our time, we thought we would structure it in two ways. I have a certain set of questions for my colleagues, and then I'll take about 15 minutes. In the last 15 minutes, I find the most interesting part is always when the audience asks questions. So why don't I start with Graham, with you. You mentioned reinforcement learning and meta-learning as some promising area of research. Can you talk about what excites you in your field, in the academics realm?
Sure. So in particular, reinforcement learning, I don't work a whole lot on this area. I actually mainly work on time series modeling, computer vision. But I think reinforcement learning is particularly exciting because, as I mentioned before, it's fueling this move from learning in the cloud to learning in the physical world. So reinforcement learning is all about complex decision making and learning online. So online just means that we have a learning system that's engaging with an environment. It's receiving very weak supervisory signal, and it's trying to make the sense of what's going on in the world. And so what's interesting is both reinforcement learning and deep learning, which we mentioned before, have been around for quite a long time, but they've been working somewhat in their own silos. And it's recently that these fields have begun to talk to each other. And also reinforcement learning scientists have started to consider really practical, big problems. One of the best examples of reinforcement learning working with other types of learning paradigms is, of course, the AlphaGo system. The system that was developed by Google DeepMind that beat a grandmaster in Go 4 out of 5 games. And this was a tremendous success. So a couple other areas beyond reinforcement learning that I think are particularly interesting for the advance of machine learning. A lot of the current technology is based on something called supervised learning, and this is the idea of giving very strong signal of sort of input-output pairs. Teaching a system, it makes predictions, you tell it whether it's wrong or not, and you feed back that into the learning system to make it better. But it's very, very data hungry. So these types of applications in vision, speech and language processing and so forth have typically been trained by millions or more examples. So to give you an idea of this, the current machine translation systems are trained on hundreds of millions of sentence pairs. But humans don't learn from millions and millions of observations that are explicitly labeled. They learn from very, very few examples. So there's an area called few-shot learning, which encompasses one-shot or even zero-shot learning, which is more human-like, that we can get machines to learn from just very few examples. And some of the strategies for doing this might be something called transfer learning. So this is transferring between different tasks or problems, which is what humans do. And also unsupervised learning. So the idea of learning without a teacher telling us what's right or what's wrong. And finally, the other area that I think I would point out, because I am working on this area and I think it's very exciting, is the idea of explainable AI. So this recognizes the fact that the most performant AI systems, like deep learning, are quite opaque. So they can give you a very accurate prediction, but they don't often tell you, or they can't even explain to you why they arrived at that answer. So in order to build trust in these systems and to open them up to non-computer scientists and other applications where other non-computer scientists are involved, we'd like to make these systems interpretable and explainable, and we're working on that now.
Thank you. And Daniel, on the venture creation side, what are some of the really promising AI ventures that you're seeing? And for the founding entrepreneurs, what are some of the AI challenges that the obstacles they need to overcome?
Well, I guess in our experience over the 75 that we've seen, and next year we'll go up to 100, there's been definitely a trend in medical imaging, a lot of stuff happening in that space. There's a company that I'm particularly fond of right now in Waterloo called Elucid Labs. And what they've done is not so much train an algorithm to recognize and label medical images, but they've also created a new sensor. So they're creating a new stream of data that is interpretable by their algorithm. And they're able, as far as I can tell, they are able to predict melanoma about a month before a doctor would be able to detect it, or even somebody doing any kind of scan. So that's an interesting one. There's a few unannounced funding rounds that I can't really talk about, but there's interesting stuff in I guess there's two umbrellas here. There's the stuff that's pure deep learning and AI focus, which is I get excited about the AI, the frontier stuff. So how do we build memory into algorithms? How do we explain AIs? And that will have huge impact on regulated industries. So when you're talking about banking, when you're talking about healthcare, without having this lens into the predictive element and understanding why it predicts a certain thing, that's a very crucial part in that. And whoever solves that will be, the companies that solve that will be very, very successful. Then on the other side, there's all the related industries to this almost boom in AI. So all the sensory stuff, all the new areas that are generating data. There's a talent grab right now around deep learning architectures and chips. We've got two companies right now, one based here, one based in Seattle, and they're working on kind of the whole software layer that goes into the training and integrates and translates what the learning chips are doing. So those are very interesting. In terms of the challenges, I think access to data is one of the big ones. Access to useful data in an environment that is trainable and that also has direct commercial application is a big challenge. And then communicating and translating to investors the difference between an AI first company with a team of 20 data scientists who are solving really tough problems versus a company that's maybe 2 or 3 people that are using some form of commoditized AI. And both companies can be very successful. They can both be very profitable. It just depends. What we try and guide our entrepreneurs is you've got to find the right investor for your company. If you're in the medical space and it's 16 deep learning engineers, you go after a certain kind of investor. If you're in the customer service space and you're creating conversational interfaces, that's a completely different kind of investor that's going to be interested in that. So a lot of the times it's just matchmaking, and that's where our kind of AI that we've developed internally over the last 2 years has been predicting what company is going to resonate with what investors and in what space, and how do we translate that so that it resonates with that field and that space.
Okay. And Graham, turning back to you, I think you received your PhD in 2009, right? So that would be considered the winter of neural network research. In Toronto, as a group of misfits that were studying AI against the grain of academic thought. So can you describe that time a bit? And also, in your view, how large were Canada's contributions to the field of AI?
Okay, so I often get asked this question, how did you end up in the Toronto lab in 2004 to 2009 and then going to NYU between 2009 to 2011? I mean, it was a pretty incredible time to be in those labs. I'm totally blanking on the name of the character in Silicon Valley that sort of bumbles his way through these different ventures, but it feels like I made, I guess, good decisions, the right decisions, but there's no way I could tell just how influential these groups were going to be. And I was deeply impacted by not only my advisors, Jeff Hinton and Sam Royce at Toronto, and Jan LeCun, Rob Fergus, and Chris Bregler at NYU, but also the students and the postdocs that were working in those labs at the time. And I think what was really different about those places compared to a lot of research groups I've seen over the years is that the teams were very collaborative. It wasn't top down at all, sort of the professor sort of giving ideas to students and each of them running on their own projects. The students were always collaborating with one another. They were co-authoring papers, sometimes even without the PIs involved. They were pursuing new opportunities and they had the freedom. So I guess it was around 2008 when this Netflix challenge came up, $1 million to come up with an algorithm to produce recommendations. And I remember, a couple students wanted to go after that and devote, 6 months of their PhD work to sort of aside to working on this problem. Jeff, just gave them the freedom to go ahead and do this. And that led to many insights within the lab. So it was, again, the amazing people, the freedom, and also the faculty members being freed up to really focus on research. So these faculty members I work with, they didn't have a ton of administrative duties. They had some moderate teaching, but they had time to really be in the lab. And I remember Jeff as an advisor always coding, working on new problems, always just solving something, running it out to the students and saying, look, I've just found, he was very hands-on, very involved. In terms of the outside of these labs and what's ensued in the years, we have to owe it to the perseverance of researchers and also the trust and support of funding agencies like NSERC and CFAR. Some people would venture to say deep learning was born in Toronto. If it wasn't born in Toronto, it certainly grew up and matured in Toronto. It went out to be a rock star, and it's really difficult to overstate how influential it is. Research is really a complex graph of dependencies. We don't start from a blank state. Researchers build on the work of others, they attribute to others, and you can see how much work has been attributed to the Toronto and Montreal labs in particular. It's something we should really all be proud of as Canadians.
I hear that about Jeff, that even his grad students right now are still amazed that 11 p.m. in the evening he'll submit some code to them. So still at his 69 years of age, he's still coding away, which is inspirational. So we spoke earlier about the fact that a lot of the commercial benefits of AI have flowed out of the country. So Daniel, what's your perspective on whether Canada is still a leader in AI and what we have to do to be able to benefit economically from AI?
I mean, on a commercial, from a commercial angle or in the research angle?
More on a commercial angle.
I mean, I would question whether we've ever been a leader in AI on the commercial angle. I mean, the big acquisitions of startups that you've heard in the last 5 years coming out of Canada have essentially mostly been acqui-hires. Mm-hmm. It's companies who've raised a little bit of money, built unique research teams, and those have been acquired by some of the forward-thinking large AI companies or tech companies out there. When you think of Baidu, that has I think 1,300 AI researchers, invested $3 billion over the last 3 or 4 years, that tells a lot. So yeah. I think that we have all the right building blocks to become leaders in AI on the commercial side. We're starting to see a lot of the local corporations build out their data science teams, engage with the research community, engage with the innovative entrepreneurship side of the economy. So we have all the right building blocks, but I don't think we're that yet.
Yeah, interesting that you mentioned some of the commercial research labs. There certainly has been a change in machine learning research happening more in industrial labs than in academic settings. And that's true throughout the world. If you look at machine learning profs at Stanford or Berkeley or Cambridge, most of them are on leave. They're all working and collecting big paychecks. And frankly, that's a pretty frightening thought, to think that the field of AI is being advanced with a corporate agenda. And there's no counterpoint as an academic counterpoint where there was enough critical mass, there was enough funding, there's enough interesting data sets to work on. And a lot of the structure around how we set up the Vector Institute was to provide that counterpoint. And I certainly will feel safer if AI is being led from an independent academic perspective than a commercial enterprise. So recently, not just for Vector, but also throughout Canada, in Montreal and in Edmonton, there's been a significant investment into AI research to the tune of $500 million that have been announced just over the last 6 months. So let me turn it back to Graham. Graham, do you feel that all of that Canadian public money is well spent? And will that help us become a leader in AI research again? And will that be enough of a counterpoint to the amount of money that the Googles and Baidus are spending on AI?
Certainly, I applaud the federal and the provincial governments, the private sector, for investing into fundamental AI research and allowing us to take this outside of the labs and commercialize it. I don't believe that funding should stop now that these programs have been established. I mean, we're creating 3 huge research institutions, one in Edmonton, as you mentioned, one in Montreal, and of course Vector in Toronto. We're looking at recruiting and supporting CFAR research chairs in AI, and these people need to be supported for the long term because research takes time. So I think that we certainly need sustained support to maintain our leadership in AI, but this is a fantastic start.
Great. One of the things that I'm currently involved with is AI education. So I wanted to talk about that next. I think there's a lot of funding being put towards graduate school AI advancement, but I think that can be taught earlier in the curriculum. I am currently working with the University of Waterloo to help them launch an undergrad AI stream that's being led by Pearl Sullivan, who's the Dean of Engineering there. And I think that would be a great program to have AI being led by our leading undergraduate engineering school. But Graham, you have some perspective on how AI should be taught earlier on. NextAI should certainly reach as promising undergraduates. So you're already involved with teaching undergraduates AI. So can you give your perspective on how you think we should approach AI teaching?
Sure. So I think there are a few aspects of the area of AI that are particularly supportive of the ability to teach undergrads and even high school students in some cases. So I think as a research field, it has one of the lowest barriers of entry to get involved. So compared to, say, a wet lab situation where you have very expensive equipment and consumables, in AI, of course, computation is very important. We talk about GPUs and all these things. But really, you need a computer and a good GPU to get started. The second thing is that there's been a very close connection between the AI community and the open source community. So over the years, tools have been developed and matured to some very, very powerful frameworks that are well documented and allow students to get involved building, not spending a lot of time in the details, but getting new machine learning systems off the ground. And then finally, I would say that in this field, dissemination is really fast. So machine learning is always used more of a conference than a journal model, and that has a much accelerated timeline for review. And researchers are now experimenting with different sort of more open platforms, the archive and other alternative publishing models, to disseminate information even more quickly. So these three aspects make it sort of a good environment to train undergrads. Now, in terms of strategies, in the classroom, I certainly balance the theoretical material, which there is some of, with the practical. So I run the classroom both at NextAI and in my teaching at the University of Guelph in an inverted model. So students work on the theory at their own pace, in their own time. They bring their questions, the tricky bits, the things they want to discuss into the classroom. We talk about them. And we also work on programming examples. So we're currently using TensorFlow, which is a framework that Google has developed. Looking maybe next year, looking at PyTorch, because people are very keen on it. So we try to do these things, like we switch frameworks every couple of years, give exposure to different platforms. And then finally, I think it's great to have undergrads and even high school students engaged in research as well as just the teaching aspect of it. Again, because of this barrier to entry, we can bring them into the lab, though I would caution, because of the amazing amount of material and sharing of information that's online, there have been platforms that have developed that are essentially promising to teach you deep learning in 7 days or 7 hours or something like this. And so because there are so many courses online, you really have to be choosy about what you're going after. I mean, certainly these might teach you how to deploy one particular type of supervised learning to problem X, but to really make these contributions and tackle the big problems, it takes dedication, it takes time, it takes hard work. And so I want to make sure students that understand that, even though that information, those courses are available.
Yeah. One of the wonderful things that the Creative Destruction Lab has introduced this year is to invite high school students to be participants in their sessions. So Daniel, do you have a perspective of how high school students or high schools should be preparing their students for an AI-led future?
Sure. So we've started it on two sides. One is just to educate people much earlier on how to develop this entrepreneurial mindset that we're trying to instill in our MBAs. So that's the kind of the baseline. The second and the easy answer that I can give you is you've got to learn to code, go into STEM, learn to code, learn anything that's computationally intensive. But the more interesting answer, which I think ties it all back to kind of the future economy that's driven by AI, is we're trying to build in these young minds this idea of lifelong learning. You've got to be able to adapt very quickly. People will no longer have 1, 2, 3 jobs in their careers. You might have 20. So being able to constantly learn new things, new skills, and kind of roll with the punches is, I think, a critical skill that they need to be developing at a much earlier stage. It ties into, there's going to be a lot of changes. We're seeing, corporate Google has this now, Google Fellowships. You have people who are going to do research in academia, academic research at Google. What does that mean for our public institutions? Are we going to privatize a lot of the research that's being happened? Are you going to be, so I won't go further there, but it's the idea of instilling in them lifelong learning.
I couldn't agree more. I have 2 daughters, they're 8 and 10, and I have them in a Montessori school for exactly that reason. Highly self-directed learning and always learning new things. I also teach them Python coding, and they're fascinated with the fact that Raquel Erdison teaches cars how to drive on their own using Python. So they see a direct path to what they can achieve. A lot of people in these panels are come and are concerned about what AI and automation will do to their jobs. I actually think that AI will, for our generation, it will enrich our lives. It'll make us more prosperous and healthier. But when I look out for my children's future, and when they graduate from school in 20 years' time, and I think yours are even younger, right? Like that's the point I start getting concerned. Like, what will future careers look like in 20 plus years? And I echo Daniel's sentiment that it's learning to learn and being very adaptable is a key requirement. How about you, Graham? What do you say? The last question goes to you. How are you going to prepare your young children for their future?
I certainly agree with a lot of things you said about being adaptable, learning to learn, developing their programming and so forth. I think I'll go back to what I said in the introduction. There's these jobs that are purely physical or purely cognitive, and those might be the ones that I would encourage my kids to stay away from. So develop both parts of their brains. Be open to new ideas. Be diverse. Be prepared to change jobs if need be. To just re-emphasize what you said, sort of just develop computational thinking. This doesn't, I have a 2-year-old and a 4-year-old right now, so it's not at the level where they're programming. Developing computational thinking doesn't necessarily mean more sort of screen time, but there's ways to engage with your kids, work with them to understand these fundamental concepts, which will lead to programming, which is, of course, a fundamental language on its own. And I think the last thing I would say is I have both a son and a daughter, and so ensuring that both of them have the equal opportunities to succeed in this new era.
Okay, very well said. Well, thank you for that. We have, I think we have about 10 minutes for questions from the floor. There's a microphone over there, so if anybody has one, just put up your hand. I think I see one over here.
Thank you very much. It was a great session.
It's on now.
No? Okay. I'm Harish. I'm the chief data scientist to the Sky Guys, a startup company working out of Oakville. I have a couple of questions for you. One is this rebirth of AI, right? We talked about reinforcement learning. I did this as a part of my master's in 2002, 2003. What factors have influenced them coming back now, and why at this point of time that reinforcement learning, deep learning is becoming so big? It's one of them. The second question is the practicality of AI. We're still talking about AI in the research labs. How much of that is practical in small industrial applications that we really will move forward businesses? So any thoughts on these two?
Do you want to take the reinforcement?
Sure, I'll take the first part of the question. Yeah. So in terms of the reemergence of AI, you may have heard this before because the same 3 things always get thrown together. It's essentially we had a lot of these architectures, whether it's deep learning or reinforcement learning, even in the 80s and 90s. So suddenly they're more successful. One thing is data, right? The access of the data to actually train these models. And I said today's architectures are very data hungry. We'd of course like them to learn from very few examples, but they're not quite there yet, right? So large data sets have propelled these systems. We've had the hardware technology advance to the point that we can train on these large data sets. So things like GPUs have made a huge impact in the community. And of course, there have been advances in algorithms. A lot of these things are in principle the same as they were in the 80s and 90s, but of course there was a lot of work in the ensuing years to make these systems more robust. For RL in particular, reinforcement learning, I think the most important thing has been the cross-pollination between the disciplines. So I mentioned sort of RL and deep learning existing in silos before. DeepMind has been really crucial to this. This is a division of Google. They had deep learning scientists start to work on reinforcement learning problems and brought a lot of ideas to just get things to work. A lot of deep learning is engineering, and they actually were able to scale these RL problems up to much larger tasks, much more realistic tasks. I mean, there's still a ways to go, but I think it's this crosstalk between the fields that's really propelling reinforcement learning forward.
Your second question was around how practical AI is in a smaller setting. And it is true that the field has been advanced by giant tech companies who have access to infinite amounts of data. And the early models required a lot of that vast majority of data. But increasingly, the researchers what they're really focused on is how quickly you can learn an algorithm. So they're getting, the learning rate is getting much, much faster, which means you don't need as much data. Also, Graham mentioned one-shot learning. So just being able to see one image of something and making a generalization of that. That's a field that's rapidly evolving, and certainly there's a lot of scientists working on it. There's another thing that makes AI more practical is that you can take work that's being done to train, say, one classifier to solve one task, and then you can use that as a baseline to train it to do something else. And that helps you, for example, if you're in a small lab and you're trying to do some medical imaging and you have a smaller subset of images to work off of, you can sometimes take a classifier that's already been trained on a similar data set and then transfer that over, certainly like start out with that and then you refine it further with a smaller data set you have. But AI will become more and more accessible, both the software systems, the platforms like TensorFlow, et cetera, are making it more accessible. There's going to be more people working on this, and a lot of this is being published. GitHub, where a lot of software code is stored, is also starting to store a lot of these models. So you can just take an acoustic classifier from one Git repo and apply it for your application, et cetera. So it's very interesting how quickly it's becoming more accessible. Any other questions over there?
I was wondering, you both, left and right, both mentioned AI safety, and I'm wondering if in your organizations, if you're participating in any international movement towards regulatory oversight of AI. That's something that Elon Musk is investing in, and you know all about that. I'm wondering if you could speak to that.
Do you want me to start? Or?
Sure, you can start.
I'll let you talk about the vector perspective, and I'll start from my perspective as a researcher. So I was fortunate to receive an award from the Canadian Institute for Advanced Research called, it's part of the Israeli Global Scholars Program. So there's researchers that are taken from 9 different disciplines. So one of these is learning in machines and brains, and that encompasses both computational and biological learning. But there's other fields, say quantum physics, and focus on the microbiome, improving societies and so forth. So the nice thing about this program, I just got back from Banff on the weekend where the global scholars met. There's a lot of dialogue between these different disciplines, and that's one way I'm working to discuss issues related to the safe deployment and development of AI as it pertains to these different scientific fields. Another effort that CFAR is establishing, you can go read about the way that they're managing the Pan-Canadian Artificial Intelligence Strategy on their website. They've proposed to establish a new institute or a new program in AI for society. And I certainly look forward to being part of that dialogue as well.
Right, to the Canadian government's, federal government's credit, when they announced the $125 million towards AI funding, that is being administered by CFAR, and part of that money is devoted towards the ethics and safety of AI. So the Canadian government is ahead of the ball and thinking about the dialogue that we as a nation need to have on it. Also, reflecting on my earlier comments, the counterpoint is that AI is going to be advanced by Google, Amazon, Facebook, Baidu, et cetera. And I'm glad that there's a set of Canadian public institutions who are very transparent and offering their researchers research freedom to advance the field of AI. Without this funding and without the bets that the Canadian government's making, there wouldn't be a counterpoint to the commercial efforts. I think the recognition that Canada is a leader and a thought leader in this thing is reflected in a big conference that the CDL, the Rodman School, is putting on. Daniel.
Sure. So we're at a business school. We're an accelerator at a business school, and part of what happens in the background is that there's a group of faculty that study entrepreneurship, study competitiveness, and since we started developing early thoughts around the economics of AI, which led to the conference, now it's led to convening of a working group by the National Bureau of Economic Research, which is kind of the head of all the economic thought leaders in the U.S., led by Professor Agarwal, who's the founder of CDL and also associated to Next. They're gonna meet, I believe, in Niagara-on-the-Lake in early September. This is the first working group that's been convened outside of the U.S., and it's specifically the top economists in the U.S. Working on kind of the economic implications of AI. So we expect to see some very interesting things come out of that, and we're definitely working on keeping Canada and the Canadian economy focused on what are the transitional effects in our economy that we need to be thinking about.
Yeah. 3 Nobel Prize winning economists are flying in for that, so pretty impressive. I think we have time for one more question. Over at the back.
Good morning. I work for CIBC, a bank here in Toronto, and we can see a lot of opportunities to collaborate, especially with the research that's being done from Guelph. And I'd like to know how we can get involved with some of the research projects that you have. I work in the information security field, and we're interested in cybersecurity.
Okay, great question. The Vector Institute is unique as an academic institution because we want to work very closely with industry. Historically, a lot of the graduates only saw opportunities to the US. And I think it's very important to bring those industrial collaborations into their academic years so they start creating connections. They understand what a professional career looks like here in Canada. Also, now that deep learning has come through its long, deep winter and it has shown what it can do, it's now, what used to be highly theoretical work is now highly applied work. So there is, the researchers there can now apply their wares to a whole bunch of different applications, and it's those applications that will help them refine their algorithms better. So a lot of the researchers, what they really want is they want access to unique and large data sets, and that only comes from a close collaboration with industry. So just to give you a quick sense of scale of the ambition for the Vector Institute, currently there are 6 profs and 31 grad students. And that's growing to faculty of 40, to 10 plus postdocs, 250 grad students. So it's literally growing in terms of scale by an order of magnitude. And all of these individuals will be will have more capacity to work with industry and on interesting data problems. The Vector Institute is also set up to do that with a supporting cast of industrial relations people that will basically do matchmaking between a CBC and a researcher that may have an interest in that area. And unique to a school, it will have a professional software engineering team led by a CTO, and that software engineering team's responsibility is to take some of the theory into application, into commercial use, and also will help some of the researchers be more productive by enabling them to clean the data sets and also to build some of the software platforms that they're not typically used to. So yes, the Vector Institute is very much keen on working with people and industry, so I'd be happy to have a conversation with you after this session. I think that runs us to the end, so thank you very much for your time.